Hello, students. Have you ever thought about this? When you mix salt in water, it just seems to disappear. Poof! But if you mix something like milk powder, the water turns all cloudy. Well, most things around us are actually what we call mixtures. So today, we are going to look at three very important types of mixtures that we see every day: solutions, colloids, and suspensions. And we're going to figure out what makes them so different from each other.
So, what's on our agenda for today? First, we'll do a quick introduction to mixtures. Then, we'll learn all about what a true solution is. After that, we'll explore the interesting world of colloids. And then we'll move on to understanding suspensions. Finally, we'll put them all together and compare them, so you'll never be confused again.
So, let's start at the very beginning. A mixture is just a substance that's made up of two or more different components. But here's the most important thing I want you to remember from today's lesson: how these mixtures look and act. Whether they're clear or cloudy, or whether the particles settle down or not, it all depends on one single thing. And that is the size of the particles inside them. That one property changes everything.
Okay, let's do a little thought experiment. Imagine you're in the kitchen. You take a spoon of salt, put it in a glass of water, and you stir it. And it vanishes. But has it really gone? Of course not. So where did those tiny salt particles go? This simple, everyday action is actually creating the very first type of mixture we're going to study.
This brings us to our first category, and it's probably the one you know best from your daily life. It's called a true solution.
Now, a solution is what we call a homogeneous mixture. It's a bit of a scientific term, but all it means is that the mixture is exactly the same all the way through. It's uniform. Just think about making nimbu pani. Every sip you take tastes exactly the same, doesn't it? That's because the sugar and salt particles are spread out perfectly and evenly in the water.
Now, every solution has two parts. First, there's the solute. This is the stuff that gets dissolved, like the sugar you add to your water. It's usually the smaller amount. Then there's the solvent. This is the substance that does the dissolving, like the water itself, and it's usually the larger amount. So, a simple way to remember this is the solute dissolves in the solvent.
So what makes a true solution special? Let's look at its properties. First, as we said, it's homogeneous. Why? Because the particles are incredibly small, less than 1 nanometer. You can't see them, even with a powerful microscope. Because they're so tiny, if you shine a light through a solution, the beam just passes straight through. It doesn't scatter. Also, you can't separate the salt from the water just by using a filter paper. And finally, solutions are very stable. That means the salt will never settle down at the bottom, no matter how long you leave the glass standing there.
Okay, but sometimes it's not enough to know that salt is dissolved. We need to know how much salt is dissolved. Is it a little salty or very salty? This measurement is super important, and we call it the concentration of the solution.
Now, one of the most common ways to calculate concentration is called mass by mass percentage. The name might sound a little complex, but the idea is actually very simple. It's just a way to compare the mass of the solute to the total mass of the whole solution. The formula is right here. You take the mass of the solute, you divide it by the total mass of the solution, and then you just multiply by 100 to get a percentage.
Let's work through an example together, nice and slow so it's perfectly clear. Let's say we dissolve 40 grams of salt in 320 grams of water. Okay, step 1. What's the mass of our solute, the salt? It's 40 grams. Step 2. What's the mass of our solvent, the water? That's 320 grams. Now here's the important part. Step 3. What is the total mass of the solution? Well, we have to add them together. So 40 grams plus 320 grams gives us a total of 360 grams. Now we just use our formula. We take the mass of the solute, 40, divide it by the total mass of the solution, 360, and multiply by 100. And we get our answer. The concentration is 11.1%. See? Not so difficult.
All right, let's move on to our second type of mixture. Now, this one is a bit of a trickster. It looks just like a solution, but it's hiding a secret. We're now going to talk about the world of colloids. The perfect example of a colloid, and something that fools a lot of people, is milk. When you look at a glass of milk, it looks completely smooth and uniform, right? It appears to be homogeneous. But from a scientific point of view, milk is actually a heterogeneous mixture. You see, there are tiny little particles of fat and protein that are just spread out and floating in the water. They are not truly dissolved like salt is.
Just like solutions, colloids have two parts, but we use slightly different names for them. Instead of calling it a solute, we say the dispersed phase. These are the little particles that are spread out. And instead of the solvent, we call it the dispersion medium. This is the substance that the particles are floating in.
So, for our milk example, the tiny fat particles are the dispersed phase, and the water is the dispersion medium.
So, if colloids look so much like solutions, how on earth can we tell them apart? Well, there's a fantastic test for this, and it's called the Tyndall effect. Remember how we said that a beam of light passes straight through a solution? Well, in a colloid, the particles are just big enough to get in the way of the light. They hit the light beam and scatter it in all directions. And when that happens, you can actually see the path of the light beam. It's a sure sign that you're looking at a colloid.
And you know what? I'm sure you've all seen the Tyndall effect in real life. Have you ever been in a forest on a slightly foggy morning and you see those beautiful beams of sunlight shining down through the trees? You can see the beams so clearly, can't you? Well, that's the Tyndall effect. The air has tiny water droplets in it, which is a colloid, and those little droplets are scattering the sunlight, making the beams visible to us. It's quite beautiful.
So let's quickly recap the properties of a colloid. It looks homogeneous, but it's secretly heterogeneous. The particles are too small for you to see with your eyes, and just like a solution, it's quite stable. The particles won't settle down. But here is the big difference. It scatters a beam of light, which means it shows the Tyndall effect. That's the key.
And that brings us to our third and final type of mixture for today. Now this one is the easiest of all to recognize. There's no trickery involved here. Let's talk about suspensions.
A suspension is a heterogeneous mixture where the particles are so big that they don't dissolve at all. They just float around in the liquid, or are suspended, and you can easily see them with your own eyes. Just think about muddy water, or if you try to mix sand in water. Those are perfect examples of suspensions.
The properties of a suspension are very different because the particles are so large. First, it's obviously heterogeneous. You can see the different parts. The particles are also big enough to scatter light. But the most important property is that a suspension is unstable. This means if you just leave it alone for a while, the heavy particles will all settle down to the bottom because of gravity. And this is exactly why you see instructions like shake well before use on things like cough syrups or some juices. They are suspensions.
Okay, so we've looked at all three types of mixtures. Now, just to make sure we'll remember all of this, let's put them all side by side and do a final comparison to really highlight the differences.
This table summarizes everything so well. Just look at the pattern. When we look at appearance, we go from completely homogeneous to looking homogeneous and finally to clearly heterogeneous. And look at the particle size. It gets bigger and bigger as we go from a solution to a colloid to a suspension. It's this difference in size that explains the Tyndall effect. The tiny solution particles can't scatter light, but the bigger colloid and suspension particles can. And finally, look at stability. The very large particles in a suspension make it unstable, so they settle down, while the others stay mixed. So if there's only one thing you take away from our class today, I want it to be this. The main, fundamental difference between a solution, a colloid, and a suspension is simply the size of their particles. That single fact is responsible for all the other properties we've talked about, from how they look to whether they scatter light or not.
And now, I have a little bit of fun homework for you. I want you to be a scientist in your own house today. Go and look around, especially in the kitchen. See if you can find one example of a solution, one example of a colloid, and one example of a suspension, because applying what you've learned is the absolute best way to remember it. Thank you so much for listening.